Hey guys, how are you tonight? Happy Saturday evening. All right, so welcome to tonight's live stream for calculus. We are going to talk about the product and quotient rules. My name is Suzanne Farrellock, and I'm super excited you guys are joining me on a Saturday. What better day to do calculus, right? Make sure that you are following us at Think Fiveable on Twitter, Instagram, and YouTube to stay up to date on all the wonderful things we have to offer you. All right, so in tonight's stream, we are going to be looking at what are the product and quotient rules, how to set them up, and stay organized while we do that. I'll teach you a little trick for that. And also, we're going to look at a lot of practice examples, and within those practice examples, we're also going to explore if product and quotient rules are really always our best option. We'll find that sometimes they are, and sometimes there might be some other algebraic manipulation we can do to make our life just a little bit easier. All right, before we actually jump into exploring the product and quotient rules, we need to just do kind of a little quick refresher on a couple one-step derivatives. Because we're going to need to use them in the examples that I've picked out for tonight. So go ahead and take 30 seconds on your own paper and see if you can write down these 6 one-step derivatives and what their solutions would be. And then we will compare in just a second and see if you got them right. All right, anybody want to help me out here? What would the derivative of x to the n be? Go ahead and type it in the chat feature if you know. Yeah, so I think this is what you were going for, Ari. N, x, and then in that exponent position is going to be that quantity n minus 1. So remember, essentially, we're bringing that exponent down front as the coefficient, and then we're going to also subtract 1 from that exponent, okay? Let's work across to the right. What's the derivative of e to the x? Yeah, awesome. This is the easy one. Derivative of e to the x is itself, e to the x. All right, we've got the derivative of the natural log of x, which is 1 over x. So give yourself a pat on the back if you got that one. And now let's look at a couple trig functions. What did you guys come up with for the derivative of sine x? Awesome, cosine x. How about the derivative of cosine x? Negative sine x, rock on. And then how about the derivative of tangent x? Perfect, Flanny. We've got secant squared x. Now, I'll go ahead and mention this now because this will apply as we work in as we're working through the product and quotient rules. But make sure when you have your trig functions that you always let me know what that argument is, what the angle is. So every once in a while, I'll have a student that tells me, oh, the derivative of sine x is just cosine. Cosine of what? So make sure that you're always including that angle or that argument there for us as well. Okay, so there's lots of other one-step derivatives, but I just picked this 6 for us to quickly review because we're going to end up using these in our examples for the product and quotient rules as we move forward. All right, so before we actually look at what the product rule and what the quotient rule are as rules, I want to do a little investigation, okay? When we talk about derivatives of terms that are being added and subtracted, we can just take the derivative of each term, okay? And some of you might think, well, that should work for multiplication too. I should just be able to take the derivative of each factor and be good to go, okay? But let's check out if that actually works or not, okay? Let's say that f of x equals x and g of x equals x squared, okay? I think we would all agree that the derivative of f of x is 1, and the derivative of g of x is 2x. So if we were to simply multiply those two derivatives, f prime of x times g prime of x, we would get 1 times 2x, which is just 2x. But let's investigate. Oops, what just happened there? Okay, hold on. Something funky just happened on my end. We go back into presenter view. All right, I think we're back in business here. So we had just, let me recap here since we lost what we had on our screen. We had that the derivative of f of x was 1, the derivative of g of x was 2x, and if we multiplied those two derivatives, 2x, we simply got 2x. Okay, so this is kind of intuitively what some of us might think. Oh, if I need to take the derivative of two products, I'll just find the derivatives and multiply them. But we also know that if I actually multiplied f of x times g of x, according to the laws of exponents, x times x squared would give me x cubed. And what would the derivative of x cubed be? Go ahead and comment on that in the chat. Yeah, exactly, 3x squared. So we can see that these two things are not equal to one another, okay? So Leibniz actually discovered that the product of the derivatives was not going to be the same as the derivative of the products. And that's where we had to come up with the product rule, okay? So our intuition here might be leading us astray a little bit, but that's all right. We've got to come up with the product rule instead, okay? So here's what the product rule tells us. The product rule tells us that if I want to take the derivative of two functions, f of x and g of x, that are both differentiable, and I'm taking the derivative of their product, so the derivative of f of x times g of x, it will equal g of x times the derivative of f of x plus f of x times the derivative of g of x. Now, this rule written out might look a little bit overwhelming, and that's okay. What we're going to do, though, is we're going to simplify this for ourselves a little bit, okay? I have a nice, fun, easy way for us to organize our information when we do the product rule, okay? What I do is I set up 4 boxes for myself by just drawing a quick vertical line and a horizontal line. In that upper left-hand box, I put whatever my first function is, whatever my first factor is that I'm looking at. So we'll call f of x, now just keeping things generic. In my upper right-hand corner, I put g of x. Now, under f of x, in the bottom left, I'm going to put whatever the derivative of f of x is. And in that bottom right-hand corner, I'm going to put g prime of x, the derivative of my second factor. Now, here's the cool, easy way to organize your information. We are going to start down in the bottom left-hand corner, and we are going to going up on the diagonal. We're going to add, and then we're going to cross back down. So criss plus cross, okay? So what this tells me is that my derivative is going to be starting in that bottom left-hand corner, f prime of x times g of x plus f of x times g prime of x. And that's exactly what that rule tells us above as well. But this gives us a nice, easy way to organize that information and keep track of it and not get overwhelmed in that process or that rule as we're working through it, okay? Does anybody have any questions about that setup before we try an actual example with some functions in it? No? Okay, that's fine. Awesome. If you do come up with questions along the way, feel free to add them in the chat. I'm monitoring that at the same time. All right, so let's look at our first example of product rule. This tells me that if f of x equals x squared times cosine x, we want to find f prime of x. So we want to find the derivative of f of x. Now, when I look at my function f of x equals x squared cosine x, I have a product, okay? I have x squared being multiplied by cosine x. So when I go to set this up for myself, in my upper left-hand box, I'm going to write x squared. And in my upper right-hand box, I'm going to write cosine x. And now I'm going to find the derivative of each one. What would the derivative of x squared be? Yeah, great, Ari, 2x. How about the derivative of cosine x? Negative sine x, perfect. All right, now it's time to criss and cross. So remember, we are starting in that bottom left, and we're going to do 2x times cosine x. So we're going to have f prime of x equals 2x cosine x. Now with the product rule, we're always going to add, but we got to think ahead a little bit here, okay? If I'm going to add x squared times the quantity negative sine x, what really happens when I add a negative? It's really the same as what? Perfect, subtracting. So this is going to become minus x squared sine x. We've got our derivative. That's it. F prime of x equals 2x cosine x minus x squared sine x. Okay. In my class, I don't make my students simplify any further than that. Technically, each of those terms would have an x that we could factor out as a greatest common factor. But right now, my focus is really making sure that you guys understand the product and quotient rule and just taking those derivatives. So I'm not going to worry about simplifying right now. Anybody have questions on that first example? No? Okay. Let's talk about the quotient rule. Okay, we're going to have a ton of mixed practice after this, so I'm going to tell you the product rule, give us an example, quotient rule, give us an example, and then we're going to work through a bunch together. All right, so let's check out the quotient rule. The quotient rule is going to look similar, but we're using the quotient rule when we're dividing two functions. And a couple big differences between the product rule and the quotient rule are going to be that instead of adding, we are going to end up subtracting. And also, we are going to have to put the original denominator squared down in the denominator of our derivative, okay? But in terms of our organization setup, we are going to look at it just the same way with our 4 boxes, with f of x in the upper left-hand corner, g of x in the upper right-hand corner, and f prime of x under f of x, and g prime of x under g of x. We're going to start in that bottom left-hand corner, and we're going to criss and cross again. But this time, because we are using the quotient rule, remember quotient tells us that we have 2 functions being divided, I'm going to use subtraction. So I'm going to have f prime of x times g of x minus f of x times g prime of x. And now this is the one piece that's really super important we remember. All over my original denominator squared. So my original denominator is g of x, and then I'm squaring that entire quantity, okay? That is my quotient rule. Okay, give me a thumbs up if that makes sense, or ask me any questions you have at this point before we do an example. All right, I got 1 thumbs up. Everybody else on board too? Okay, let's look at an example. This time I have that f of x equals x squared minus 9 all over the quantity x plus 5. And again, we're looking to find the derivative. Now, notice this time that I have a fraction. Fraction really tells me that there's division. So because I have division, I'm going to use the quotient rule, okay? When I go to set this up, I'm going to make my 4 boxes. My top function is that upper left, so that's going to be x squared minus 9. My bottom function in the denominator is going to be that upper right, which will be x plus 5. All right, derivative of x squared minus 9 is just going to be 2x, and the derivative of x plus 5 is going to be x. Starting in that bottom left-hand corner, we are crissing and crossing, but we've got to make sure that when we do it this time, we remember our minus. And then we're going to go back down. So we are going to have that f prime of x equals 2x times the quantity x plus 5. Notice that 2x is being multiplied by that entire quantity x plus 5, so I'm real careful to make sure that I put that in parentheses. Minus, and then I have that quantity x squared minus 9 times, oh, rewind for me. I made a big boo-boo there. Beep, beep, beep. Derivative of x plus 5 is not x. It is 1. Sorry about that. So we've got x squared minus 9 times 1 all over my original denominator squared. So x plus 5 quantity squared. Now, yeah, exactly. Sorry, Ari. I just saw your comment there after I caught myself. In terms of my derivative, do I really need to write that 1 there? No. I put it here in that initial write-out for us so that you could see the process of what I was multiplying. But this would be one where we really could easily write this as f prime of x equals 2x times the quantity x plus 5 minus that quantity x squared minus 9 all over x plus 5 quantity squared. Now again, for my purposes, I'm just looking to make sure that you guys master that product and quotient rule in terms of being able to take the derivative and set up. There are ways that we could certainly clean this up if we needed to work with it in an application problem or something like that. We could multiply 2x times x and 2x plus 5 distributing. We could distribute the minus to that quantity x squared minus 9. We'd end up with some like terms we could combine, all that jazz. But again, I'm not worried about that right now. Depending on what your teacher is specifically looking for from you, you might need to go that extra step. But I'm really just looking tonight to make sure that we master those rules. Okay. All right. So we've seen one example of product rule, and we've seen one example of quotient rule. Let's practice now. Okay. So here's the first one I got for us. If y equals sine x over the quantity 1 plus tangent x, let's find y prime. So here's my question for you, and you can answer this in the chat. Do we need to use product rule or quotient rule on this? Okay, Dylan saying quotient. Anybody else want to chime in? I'm totally in agreement with you, Dylan. We have two functions being divided here, so we need to make sure that we go ahead and use the quotient rule. Okay, now remember, regardless of whether we use product rule or quotient rule, we can still set it up the same way initially. We're going to have sine x and 1 plus tangent x. Let me see what... Yeah, so there's certainly some times where we're going to be able to maybe simplify a function up front, and that will make our life easier. In this case, I don't necessarily think there's any of that going on, but definitely good to keep that on your radar for sure, Dylan. All right, what's the derivative of sine x? Cosine x. Derivative of 1 plus tangent x is going to give me secant squared x. We're crissing and we're crossing, and this time because it's quotient rule, we have to make sure that we use the minus. All right, so we're going to have that y prime equals cosine x times that quantity 1 plus tangent x minus sine x secant squared x all over that original denominator squared. So 1 plus tangent x quantity squared. And that's our derivative. Okay. Might not look pretty, but that's all right. We've got our derivative here. Any questions on that first example? All right, here's the next one. This time I want us to find the derivative of f of x equals the square root of x times e to the x. All right, first thing, product rule or quotient rule? What do you think? Product, great, Ari. So we've got that square root of x being multiplied by e to the x, so we're going to use product rule. Go ahead and take a couple minutes and see if you can work this one out on your own, and then let's compare answers and see what we came up with. I'll give you a little hint too if it helps at all. You may want to think of the square root of x as x to the 1/2 e to the x. All right, let's see, Dylan. You got 1/2 x to the negative 1/2 e to the x plus square root of x e to the x. Yeah, I know. Sometimes it's a little tricky to type out math. That looks great though, Dylan. So if we write that out, this would give us that f prime of x equals 1/2 x to the negative 1/2 e to the x plus, now when I did this one on my paper, Dylan, same thing though, I wrote x to the 1/2 e to the x. But you're absolutely right that I could rewrite this x to the 1/2 as a square root of x. I know that when I took calculus, I always had to get rid of negative exponents. So my teacher would always say, oh, get rid of that negative exponent. So I might have been tempted to rewrite it as 1 over 2 square root of x e to the x plus square root of x e to the x. We even could clean that up a little bit further and do that as, whoa, that eraser was wider than I expected. As e to the x over 2 square root of x. But again, some of that is teacher preference, depending on what your teacher wants. But, you know, when it comes to the actual AP exam, you do want to make sure that you're comfortable with rewriting expressions with negative exponents as positive exponents. Typically in that multiple choice section, you're going to see things rewritten with positive exponents. Give me a thumbs up if this one's good. Give me a thumbs down if you need some more help or explanation or have any questions. All right, awesome. Let's keep moving. What's happening here? Why are we not? It's not letting, there we go, okay. Doesn't let me advance to that next slide. All right, this time we have g of x equals the quantity 3x squared minus 5x times e to the x, and we want to find g prime of x. What do you think, product rule or quotient rule? Let me know in the chat. Product rule, awesome. So again, we have that quantity 3x squared minus 5x being multiplied times e to the x. So that multiplication there tells me that I need to use the product rule. All right, let's set it up. We've got 3x squared minus 5x times e to the x. Derivative of 3x squared minus 5x is going to give me 6x minus 5. And the derivative of e to the x is good old e to the x. All right, product rule. So we're crissing and we're crossing, but we are going to add. So we're going to get the g prime of x equals the quantity 6x minus 5 times e to the x plus that quantity 3x squared minus 5x times e to the x. That's our derivative. As I've commented in a couple other examples as well, you may be tempted to factor out a common factor of e to the x, and then you'd be able to combine some like terms, but in terms of mastering that process of actually taking the derivative, that's what g prime of x would look like. All right, how about this one? Product rule or quotient rule? We're looking at h of r equals r squared over the quantity 2r plus 1, and we want to find h prime of r. Yeah, awesome. Quotient. You guys beat me to it before I could even finish asking the question. Good for you. All right, so this time when we go to set up the quotient rule, same setup, but we have r squared and 2r plus 1. Derivative of, tips for when the quotient rule gets super messy with big exponents and messy algebra. I'm trying to think, Dylan. They can get messy. A lot of derivatives, especially quotient rule, can get messy. I think the biggest thing is just making sure that you are organized and neat on your paper, but also that you don't try to do too much simplification in one step. So of course, with the AP exam, we're going to want to make sure that we're efficient with our time. But trying to do too much in our head isn't going to really help us either. So I always tell my students, like, make sure that you are taking every step on paper that you need to not lose track of anything. Did you have a specific example that in mind, or you've just found that that's something that you are kind of struggling with a little bit algebraically? Just going to choose polynomials in my homework. Yeah, and again, some of that's going to vary from teacher to teacher. I think a lot of time with those long polynomials, you will find that when you start to simplify, a lot of terms are going to combine. Now, when you say huge exponents, I mean, are we talking like maybe having like an r to the 100 kind of deal, or what were you seeing in your homework? Yeah, so generally speaking, I wouldn't let large exponents really throw you off too much, because even if we were to take the derivative of x to the ninth as part of the process of a product or quotient rule, we'd still get 9x to the eighth. But I don't know that that really has a big implication on us simplifying after that. We've just got to, keep track of any like terms we might have if your teacher wants you to, simplify as much as possible. Yeah, so x to the 6 or higher order polynomials. Yeah, I mean, I think you just got to be careful in terms of, check yourself at each step and try not to rush through it and look for any like terms to combine if your teacher wants you to simplify. I mean, some of them, yeah, they can be kind of messy and crazy and really long when you've got those higher order polynomials, especially if you've got like an x to the 6th, x to the 5th, x to the 4th, all the way in descending order. But don't let that scare you or freak you out. In terms of like drawing your boxes when I set it up, you just might need to draw some bigger or longer boxes to fit it all in there. But I find that drawing the boxes too, when you use the product rule and quotient rule, really help you keep your information organized. Because if you have polynomials with like 6 terms in them, it can be real easy to start losing track of, did I already take the derivative of that piece, when you're not organizing it and you're just kind of going by specifically memorizing the rule. But I think this setup, I have found for me and my students at least, this setup with the boxes can be very helpful. So I hope that helps a little bit. All right, let's go back to this problem. We had r squared over the quantity 2r plus 1. So the derivative of r squared is just going to be 2r, and the derivative of 2r plus 1 is just going to be 2. So remember, we are using quotient rule, so when we criss and cross, we've got to remember our minus, and we have to remember that original denominator squared. So we're going to have that h prime of r equals 2r times the quantity 2r plus 1 minus r squared times 2. Now, if I'm thinking ahead on this one a little bit, I would probably just write 2r squared, since that derivative in the bottom right was just a number 2. We can write it as that coefficient to r squared. All over that original denominator squared, so 2r plus 1 quantity squared. This is one of those examples where we have the derivative. Maybe it doesn't look so pretty, but it's correct. If we were to actually work through simplifying this one, you would find that there's actually some pretty nice simplification that happens. But again, some of that's going to depend on what your teacher's expecting from you at this point. Just to kind of get a feel for it, are your teachers at this point asking you to simplify or just find the derivative and leave it? Just find it, Ari? Okay. Anybody else? I think my teacher wants at least minimal simplification like combining like terms. Okay, yeah, so that's the tricky part, Dylan, sometimes is, you know, each teacher has their own expectations. In an example like this, where your teacher might want some minimal simplification, we could go ahead and distribute and get 4r squared plus 2r minus 2r squared over that quantity 2r plus 1 squared. We'd have some like terms now that we can combine. That 4r squared minus 2r squared in the numerator would give me a 2r squared, and I still have the plus 2r over that quantity 2r plus 1 squared. If we check out that numerator now, we actually have a common factor of 2r. If we factor that out, we'd be left with what? R plus 1 over 2r plus 1 quantity squared. You know, so it cleans up a little bit, but not, you know, I hate to say the word perfectly because I don't know that there's any perfect simplification, but that might be something more like what your instructor's hoping for, Dylan. Does that help some? Awesome. All right, so here's the next one. All right, we have f of theta equals sine theta over cosine theta, and I want us to find f prime of theta. How would you guys take this derivative? And well, let's see. Yeah, man, I can't trick y'all at all. Yeah, so absolutely. Sine theta over cosine theta. This is where you got to kind of be on your toes a little bit and stay aware of some possible trig identities or some basic trig relationships. Sine theta over cosine theta, a lot of students just see that division and they think, oh, I can use the quotient rule. The quotient rule would work, but there's a better way. And keep in mind, when you're taking the AP test, you've got to be efficient with your time, okay? So anything that can save you some time along the way is valuable. So yeah, really, I could rewrite f of theta as tangent theta. And now this just becomes a quick one step, and we know that f prime of theta would equal secant squared theta. Now, if you were to do this using the quotient rule, we would get the same end result, but I bet it would be a little bit faster. Well, I know it would be faster this way if you picked up on that trig identity. Do we need to know double half angle formulas or just basic identities like sine over cosine and Pythagorean identities? The more trig identities you know, the better in terms of, you know, having the ability to recognize and potentially simplify, you know, anything that might come your way, especially on that multiple choice section. So I would certainly encourage you to also know those formulas as well. I don't know that how much your teacher in your individual class will stress those identities, but those double half angle formulas every once in a while can sneak up in that multiple choice section in terms of making your life easier if you pick up on those. All right, here's our next example. We've got f of x equals x ln of x, and I want us to find f prime of x. What do you think for this one? How would I take this derivative? Product rule, awesome. So nothing fancy here, pretty straightforward. We've got that x being multiplied by the ln of x, so we want to use the product rule. Try this one on your own and let me know what you come up with. Yeah, so I agree with you, Dylan. 1 plus ln of x. When I did this one on my own paper, I actually came up with the ln of x plus 1, which is the same result because addition is commutative. When I set this up, I would have x ln of x. The derivative of x is 1. Derivative ln of x is 1 over x. So f prime of x would equal, we're going to criss and cross, 1 times the ln of x is the ln of x, plus, and now if I'm thinking ahead here, x times 1 over x is simply going to leave me with 1. Okay. So there we go. Any questions on that one? That one's pretty straightforward. All right, here's our next one. This time I want us to take the derivative of f of x equals x cubed minus 2x plus 5 all over x squared. Try this one again on your own and see what you come up with. We're trying to find f prime of x. Without actually giving me the answers, anybody willing to share with me how they approach this problem? Okay, sure. So yeah, definitely, keep factorization on your radar, definitely. X cubed minus 2x plus 5 doesn't appear to factor in this case, but that's definitely something that could be helpful. Always good to keep that on your radar. Any other thoughts on how to get started on this one? Okay, so Ari, the quotient rule would absolutely work here because we have x cubed minus 2x plus 5 being divided by x squared. Did anybody do anything other than the quotient rule? Sure, we could, Dylan. We could do, we could rewrite x squared as x to the negative 2, and then we'd have two quantities being multiplied, and we could do the product rule. That's another thought. Anybody have any other thoughts? So, Ari and Dylan, I don't disagree with either of your thoughts there, but there's an even better way, in my opinion, to do this one. Because again, remember time, we got to work with time here, and we want to be as efficient as possible, okay? Yeah, so watch what I'm going to do here. So I can rewrite f of x as x cubed over x squared minus 2x over x squared plus 5 over x squared, okay? This is what I refer to as splitting the fraction. Now, each of these terms is going to simplify, and I'm going to find that I actually just have 3 1/7 here. So if I simplify this, this would give me x minus 2 over x plus 5 over x squared. And I could rewrite that as x minus 2x to the negative 1 plus 5x to the negative 2. And now I've just got 3 quick 1/7 to deal with. So f prime of x would equal 1 plus 2x to the negative 2 minus 10x to the negative 3. Yeah, exactly, Dylan. We got to be thinking, got to keep you guys on your toes. But these are the kinds of little things that once you learn them and you get into the habit of them, you're like, oh my gosh, that might just made my life so much easier. And I didn't want to say it yet, Dylan, because I knew this problem was coming up. But when you asked me earlier about sometimes having larger polynomials, look at what the denominator is, because you might have a larger polynomial in the numerator, but if in the denominator you just have a monomial, a single term, you can split that fraction and just do quick, easy 1/7. But again, that's only going to be true if we've got that monomial in the denominator. If you had another large polynomial in the denominator as well, might not work there. But, you know, check it out. I made a comment earlier too about negative exponents. If you're somebody that feels inclined to get rid of them, we could write this as 1 plus 2 over x squared minus 10 over x cubed. Either of those will work though in terms of we have taken our derivative. Any questions on that one or splitting the fraction in general? If we had gone back and used the quotient rule or used the product rule by rewriting that x squared as x to the negative 2, we ultimately would have gotten the same result. It might have looked a little bit messier on paper up front, but they would have been equivalent answers. All right, here's my next one. I want us to find the derivative of h of t equals the quantity 2t plus 7 times the quantity t minus 3. What do you think? How should we approach this one? Exactly. It's all about those brain moves, right? We could use the product rule here. Wouldn't be wrong, okay? But this is another one of those situations where I could quickly FOIL this out, and then I would just have quick one-steps to do. So h of t here is going to be equivalent to 2t squared minus 6t plus 7t. I'm getting ahead of myself right in that too. 7t minus 21, which would simplify to 2t squared plus t minus 21, and now it's just a quick, easy one step. I get h prime of t equals 4t plus 1. Boom. Yes, product rule will work, but in terms of being efficient with our time, anytime we can make our life easier by simplifying that problem quickly up front, go ahead and do it. Turn it into one steps. All right, I'm going to up the ante on you guys on this one. I want us to find f prime of x if f of x equals 4 plus x over x e to the x. What rule should I start out with? What do you think? Should I use quotient rule, product rule? Is there some kind of algebraic simplification I could do on this one up front? So when I look at this one, first thing I'm picking up on is that there's the division there, and so I'm thinking product, or not product rule, quotient rule, okay? When I go to set this up now, I've got 4 plus x, and I have x e to the x. Derivative of 4 plus x is just 1. And now how do I find the derivative of x e to the x? What do you think? Yeah, Flanny, good. I've got to use the product rule now. So I basically am going to start all over just for this piece. And I'm going to say, okay, in order for me to take the derivative of x e to the x, I need to use the product rule. So I'm going to set up another set of boxes for myself with x e to the x. Derivative of x is 1. Derivative of e to the x is e to the x. And now I'm going to criss and cross, and I'm remembering that right here I'm doing the product rule, so I'm going to do plus and then come back down. So I'm going to have 1 times e to the x, which is e to the x, plus x e to the x. So I've got to remember where I started, though. I started with the quotient rule. So now I'm going to go back to that larger set of boxes, and I'm going to have 1 times x e to the x, so f prime of x equals 1 times x e to the x, which is just x e to the x, minus, because I'm doing quotient rule, and now I've got to multiply the quantity 4 plus x times that quantity e to the x plus x e to the x. And because it was quotient rule that I was using to begin with, I've got to do all over my original denominator squared. So this is actually a problem where I have to do the quotient rule and the product rule in the same exact example. And again, I absolutely love setting up those boxes, even more for problems like this, because it's so easy to get lost in your work sometimes, but these boxes really help us keep ourselves organized. Anybody have questions on this problem where we had the product rule within the quotient rule? No? Okay. One more example for us. This time I'm giving you guys Q of R equals the quantity 2R plus 1 times the quantity 3R plus 2 all over the quantity R plus 1 times the quantity R minus 1. Any thoughts on how we should get started on this one? Yeah, so Dylan has some great options here for us. He said we could FOIL out the top and we could FOIL out the bottom and then do the quotient rule. Or he noticed too that in the denominator, when we FOIL that out, we're going to get R squared minus 1. I personally would FOIL out the numerator, FOIL out the denominator, and then use that quotient rule. This is another one of those situations where we got to be smart about it. Could we technically use the product rule in the numerator and the denominator and then go back and use the quotient rule between those two results? Sure. Would it get messy? Absolutely. So this is just going to help make our lives a little bit easier. So let's start by foiling. All right, so we would get that Q of R, so we're not taking the derivative yet, we're just cleaning up that numerator and denominator to make taking the derivative a little bit easier, would be 6R squared plus 4R plus 3R plus 2 over R squared minus 1. 4R plus 3R like terms, so let's combine them. Would give us 6R squared plus 7R plus 2 over R squared minus 1. Now, because we did that multiplication up front there, now we can just use the quotient rule. All right, so let's set it up. We've got 6R squared plus 7R plus 1, and we have R squared minus 1. So derivative of 6R squared plus 7R plus 1 is going to give us a 12R plus 7. Derivative of R squared minus 1 is just going to give us 2R. Now we're using quotient rule here, so we're crissing and we're crossing, but with a minus. And I'm going to go down to the next line just to make sure I've got enough room. So we're looking at Q prime of R equals the quantity 12R plus 7 times the quantity R squared minus 1 minus that quantity 6R squared plus 7R plus 1 times 2R. And because it's quotient rule, this is one thing a lot of my students forget, it's going to be all over that original denominator squared. So we've got R squared minus 1 quantity squared. Okay. So this is one that certainly has a little bit of a longer answer. Don't be scared by that or thrown off by that. It's totally fine. Any questions about this example or any of the ones that we've done so far, or other questions about product and quotient rule at this point? No? So big picture, keep in mind that as you use the product rule and the quotient rule, which are very important rules that you are going to end up using a lot, you also want to be thinking, be smart about it. If there is a way that you can make your life easier up front by either splitting the fraction or maybe foiling out some products real quick, do that. Turn them into one steps, make your life a little bit easier. Just because you can use the product and quotient rule doesn't always mean that it's going to be the most efficient use of your time. So just, keep that on your radar. Thinking, having that same problem now moving forward. Let's see. There we go. Thinking ahead. We also want to make sure that we know how to use the chain rule. And then we're going to find that there are problems where we're going to end up using product quotient and chain rule in combination with each other. It's especially common to have product with chain or quotient with chain. So you want to make sure that you get comfortable with product rule, quotient rule, and chain rule in addition to those one steps. If the chain rule is something that you want some more practice on or still need to become more comfortable with, Monday coming up, we are going to have a live stream on the chain rule, and it is going to be at 8 p.m. Eastern. So I know some of you might be in different time zones. So Monday, please join us for the chain rule stream and make sure to spread the word to your friends that that's coming up as well. Unless you have other questions, I am done, but I'll stick around for a couple minutes in case you do have other questions. Otherwise, thank you for your hour of time tonight. I hope that the examples and the information I share with you was helpful, and enjoy the rest of your weekend. Keep doing math. Anybody else have any other questions? Shoot them my way if you do. I'll hang out for a couple more minutes. No? All right. Have a great night. Thanks for attending.